Hello, my name is Peter Paulson. I'm a junior computer engineering student at Santa Clara University. Today we're going to be talking about binary, which is numbers for computers. So what is binary? Binary is a number system that represents numbers as ones and zeros instead of decimal, which is its system. Hey everyone, thanks for coming. My name is Peter Paulson. I'm a junior computer engineering student at Santa Clara University. And today I'm going to talk about binary, which is numbers for computers. So what is binary? Binary is a system of representing numbers as ones and zeros, as opposed to decimal, which represents numbers with 0 to 9. In binary, each digit is exactly a 1 or a 0. Let's compare two numbers in each system. This number on the left, which is 11000011, is the same in binary as 199 in decimal. These two values represent the exact same number. So how do we get from decimal to binary? Well, we use the exact same system that we use in decimal, except for we change the place value of each digit. In decimal, we have 199 is 1 times 100 plus 9 times 10 plus 9 times 1. That's how we get 199. You probably learned that in like 2nd grade. In binary, we do the exact same thing, except for we use powers of 2 as our place values instead of powers of 10. In here, we have powers 10, 10 to the 0, 10 to the 1, 10 to the 2. In binary, we have the exact same thing. We have 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, etc. all the way up to 2 to the 7th, which is 128. So we represent the number in the exact same way. 199 is 128 times 1, plus 64 times 1, plus 32 times 0. If this down here was a 0, if this was 190, this would be 0 times 1, because it would be 0 in the place value. Plus 16 times 0, plus 8 times 0, plus 4 times 1, plus 2 times 1, plus 1 times 1. That makes 199. These are the exact same number. So how do we actually do this in practice? Well, if it's a small number, we can just look at it. If you're more advanced in your computer studies, you'll just look at that and say that looks like a 9, it's an 8 plus a 1, it's a 9. We can also do something called repeated division if we're trying to go from decimal to binary, or repeated multiplication if we do the other way. For instance, if we look at a 9 in decimal, 9 looks like 8 plus 1, which is 2 to the 3rd plus 2 to the 0th. So we know that there's a 1 in the 4th place, or the 3rd place if you're starting at 0. And there's also a 1 in the 0th place, or the 1st place if you're starting at 1. So we know that there's a 1 in the 4th place, and the 1st place, and we fill in the rest of zeros. And that's how we get a binary number. So why would we use binary? This seems like a relatively complicated system for something that's honestly going to be pretty useless. Well, it's not useless. We use binary in computers. And the reason we use binary in computers is because it's very simple to represent binary in physical systems. It's much easier to represent true or false, on or off, left or right in a physical system than it is to represent 7/10 of whatever that system is, or 3/10 or 2/10. So in computers, we use zeros and ones because those are the easiest ways to represent the data. In computers, we use electrical signals, or gates being true or false. We use numbers being true or false. We use electrical signals being high or low voltage. And we represent those as ones and zeros, and that's how we build our computers from the ground up. On the left here, this is what a computer sees. It sees, in the software, it'll see ones and zeros, and then at the hardware level, it sees electrical signals plus and minus voltage. So, any questions? No? All right, thank you.